Hello, hello, ladies and gentlemen, welcome back. In this video, we're going to be continuing our Lightwave 2 Unreal Engine series with part 2 of our Introduction to Blueprints videos. In this video, we are going to be creating our collision volume in which we both detect our player character, but also make sure that only our player character is being detected by the system. So you can think of it like, an alarm system as part of your house, has like a certain threshold of detection, right? So in that scenario, it's usually something scale-wise, right? In this particular system, we are going to be pinpointing our character, but also make it flexible that we could potentially add other elements as well. We're not really going to be adding those other elements, but that system, basically we're building a system that's robust enough for expansion. So to do that, we need to create another blueprint, and in this case, it's again going to be an actor blueprint, and we're going to call this trigger volume. And we're just going to go ahead and drop this into the scene. Now, like any other empty actor blueprint, it's just going to be represented by this little spherical sprite that is going to be uniform in scale as you zoom in and zoom out. You can change the scale of those in your actor settings down here in your details panel. But we're really not going to worry about that just now. We're going to open up our blueprint. And again, just like our light blueprint, there's not a whole lot going on in here because we need to add that in. So the first thing we're going to do is we're going to add a box collision. And let's go ahead and compile that. So in our scene, you can see that we have a box in our scene, but if we switch over to game view, it disappears. So how are we going to know where the box collision is for debugging purposes, right? So let's go ahead with our box collision selected in our blueprint. We'll scroll down under rendering, and we have hidden in game. And so if we uncheck that, as you can see, while we're in game mode, our box is now visible. Now, I didn't have that set up at the beginning. This is kind of something I thought about after the fact, and just to make things a little bit easier to follow along with. So we go back out of game mode, which you can access, by the way, by making sure you have your viewport selected and hitting G on the keyboard. But back to our blueprint and over to our event graph. Now, we're not going to be using these guys in this particular case. What we're going to do is we're going to select our box collision. We're going to scroll down to our events list, and so these are all the events that can be triggered by this collision. And technically you can add more of these by creating custom events. However, for the time being, we're just going to worry about these two. It's going to be on component begin overlap. We'll go back here, and we're going to want the one that goes with it, on component end overlap. And so as you can see, it's referencing specifically our box here. If we were to change the name of this box, this would also update, or should update unless there's a bug. Now, what we need to do is not only detect when anything overlaps the box, we want to filter down to, in this particular case, just our character. And we're going to do it using two different means of filtering this. We're going to do it in a way that allows us to, at any point, add items that we want to allow to be detected by the system. So we're basically going to filter out everything that we don't want and just allow what we want through. In this case, it's just going to be our character. But you'll see as we go that we could theoretically, have other elements in the level, whether it's friendly AI or bullets or whatever. We can assign tags to these particular items that allow them to also trigger the system. Now, there's another way of handling this as well. It's called getting all actors of class. And depending on how complex of a project you're doing, getting all actors of class can be good or it can be detrimental. And really, it's just a performance issue. If you have a big project, anytime you search for all actors of a given class, Unreal Engine has to search all the classes that are active in your level in order to find out what is what. It basically has to do a check. Is this actor part of this class? Yes or no. Is that actor part of this class? Yes or no. However, if we're just using tags, we're basically just looking at the specific actor that is colliding with our object and going, do you have this tag? And so it's a much lighter weight and more performant method. We will be using both in this system, but you'll understand why I'm doing it this way versus the other way in this particular part as I go. There's a third option, and it's called gameplay tags. Now, gameplay tags ultimately are what you'd probably want to use in this scenario to filter everything. The problem with gameplay tags is that it's a little bit more of an advanced thing that kind of demands its own video. And there's currently there's plenty of help out there already in the community about how to use gameplay tags. Unreal Engine's documentation is really good, and is usually up to date every time they release a build. And so if you really need to know that right now, you can go ahead and look that up. But for now, we're just going to deal with simple tags and getting all actors of class. All right, so in our onComponentBegin overlap event, we have this pin called Other Actor. And this other actor is going to be the actor that is currently colliding with our box. Now, this can be multiple things at once. You can have multiple actors come out of here. And so basically this is going to fire off every single time a new actor collides. And so it's going to get this information. And so what we need to do is we need to find out what tags are associated with any actor that collides with our collision object. So we're going to get tags. And so, as you can see here, tags is outputting an array of information. Now, if you don't know what an array is basically any collection of items within the engine. So it's going to be, it could be an array of variables. It could be an array of a single type of variable. It can be an array of different types of variables. It can be an array of position, location information. It can be objects. It can be lights. It can be whatever. In this particular situation, it's basically going to be strings of text. However, we don't have any yet because we haven't created any yet. So what we're going to do is we're going to grab our character. With the character selected, we're going to, in our searching of our details here, we're going to type in tag. And under the actors group, there's a tags section, and we're just going to hit add element because we currently have 0 array elements in here. We're going to click on that. We now have a single array element in here, and we're going to call this player. We can call this anything we want, and that's important because I could call this Timbuktu, and anything with the Timbuktu tag on it could therefore be detected by our collision detection. But just keeping it simple, keeping it straightforward, we'll just call it player. And so back to our blueprint. Now that we have our tag created, we're going to drag a pin out from our tags array, and we're going to type in get, and we're going to get a copy of that array. If you hadn't noticed already, this little grid icon, this grid box, is an array icon within the editor, so anything with this kind of box grid shaped thing is just the icon for an array. So it may not be this color, but that is the icon for an array. And so now that we've gotten our reference here, and because we only have one element in this array, and every array starts at 0 and counts up, we know that this is the correct item in that array that we need. And so from here, we're going to drag a pin out, hit the equals button, and we're going to select equal name. And so we're basically getting the name of this tag, and then we're going to compare it to a name that we set. All right, so we drag a pin out from here, click promote to variable, and then we're going to call this player. And again, we're only calling this player just to simplify things. You could name this a more abstract thing like tags that can overlap or something like that, or tag that overlaps, to be a little bit more concise because it's a singular. And again, because we haven't compiled yet, we don't have access to the default value of the variable. So in here, we're just going to type player, and we're just going to compile that again. So all we're doing here so far is we're getting our tag, we're getting our reference to that specific tag in the array. We're getting our array of tags, getting a specific reference to the specific array element that we want, and we're comparing that with the one that we're storing in memory. From here, what we want to do is we want to create a branch. A branch is just Unreal Engine's version of a Boolean variable. So it's a yes or no, true or false statement. All right? So we want to know, is the tag we're looking for equal to the tag that's coming in from the other actor, true or false? And so if it's true, we execute this code. If it's false, we execute that code. Or in some cases, we don't execute anything at all, depending on what we want to do. So you could literally just have it come off true and then not do anything for false, and that's fine. Unless you need to do some specific thing like if nothing is true, then everything dies, kind of thing. We're going to compile that. Now, at this point, under normal circumstances, I would want to save whether or not something coming out of here is true or false, but we really don't need to. So normally I would go ahead and create another Boolean variable that I can then store whether or not this is true or false. In this scenario, I don't really need to. Storing that information doesn't really get us anything. And it's just extra nodes that we don't really need at this point, so I'm going to bypass that from what I actually have in my notes. But if you need to create a variable, again, just go here, select that variable, and tell it what type you want to be, give it a name, give it a default value, etc. But from here is where we start dealing with getting all actors of class. Now, the reason why I'm using getting all actors of class here is just to show another way that we can capture a large array of actors within the scene and then do something with them, right? So since we want to detect our lights at this point, we're going to do get all actor, oops, of class. Okay. So the reason why we want to talk to our lights, because now we have to tell them, now that we've filtered through that we are accessing our character, it's what do we want our lights to do, all right? And how do we find them? How do we communicate with them? So we're going to go ahead and get our rotor lights BP, which is our the class name for our rotor lights blueprint. Compile as you go if you want. Now, if we only wanted to talk to a single light, we could go ahead and do get again and then tell it what light we wanted if we knew that that would be a consistent result every single time. However, getting the 0 element from an array and being the same result every time is really only going to work if the array is created by you and you know the order in which things are collected. Now, the game engine, depending on when the object was created in what order, and it could. I've had problems where like that order gets rearranged by the engine at any time. It's not something I feel like I can rely on, and so I don't necessarily want to get this at this point. I could still do it, and then get the length of the array and then what have you, but we really don't need to do that. In fact, it's kind of a waste. What we're going to do, because we're going to want to talk to multiple items at the same time, is we're going to do for each loop. And essentially what this is going to do is when this executes, it's going to get the information on the array that you're doing this for. And for every item in that array, it's going to fire off an event. Or say it's going to execute this path over and over again for each item in the array. That's probably a better way of putting it. So since we are getting our rotor light blueprint here, if we go ahead and open this guy back up, bring him over here, you can remember that we have this can rotate variable. We need to talk to this variable. Now, because we're getting all actors of class, this array element here knows what variables are in this blueprint. So we can go ahead, drag a pin out from here, and we're going to type in can, and as soon as you start with that, it predicts that you're looking for that variable. Now, we're going to set can rotate, but you can also get that information. So if you're trying to read information from another blueprint, you can do that too. Or you can set that data from here. So we're going to set can rotate. And because this is path for truth, we're on the path for truth here, we're going to make that active. All right, now, of course, I'm kidding about the path for truth. That's just a thing. Meant to sound funny. But because we're executing on the true statement, we want to make sure that this is true. Now, we may not always want want every light that's associated with this particular alarm system. Maybe we're using this light in multiple places. Maybe we have some that are just on, maybe we have some that are just off. Maybe we have different alarm groups within our level. And so if we just leave this as is, it's going to affect every light rotator in our scene, every rotator light blueprint that exists within our scene. So we're going to want to add another filter. The great thing is that we already have that code here. All we have to do is replace this variable. Now, Unreal Engine is great at handling things like, we can collapse nodes into a group that is just kind of a one-off, but we can also create functions and macros. I'm not going to do that here just because I don't want to. I would do it in an actual project. I'm not going to do it here, because I think that's a video unto itself, but also, or part of a different video once we start doing more complex things. But I wanted to make sure that we could still see the entire chain of events because I want to cover debugging, either in the next video or if we encounter an issue while I'm recording this video. Don't think we're going to encounter a video because I think I've worked through all my bugs while setting this up, but who knows. However, from here, we can literally just copy this bit of code, paste, and then from here, from our for each loop, just type branch and set up another Boolean function. And we're going to take this variable and delete it, and we're going to create another one. And we're going to promote that to variable, and we're going to call it light tag. Sure. We're going to compile so that we have access to our thing. And of course, this errored out because I didn't plug that in there. Let's compile that again. Now it's reading that information. And so here we're going to call it, we'll just call it zone 1. All right. But right now, this variable isn't associated with our light. So let's go ahead and select here. We don't have a tag currently in here. So we're going to call this zone 1. Now, it's important to note that we could have one light in multiple zones or in multiple tags and reference those. So depending on the setup, you could perhaps put an integer variable plugged into here where you could say, I want, this particular trigger volume to only affect lights that use, maybe whatever's in tag slot 2. All right, and so you could set that in here, but you could also expose this variable, and just like we did with the light, expose it from our details panel here. So I'm not doing that here, but just so you know that's something that you can do to help make this kind of easier to use in multiple places. All right, so now we don't have to connect anything to false because when this fails, nothing needs to happen, and that's fine. But you may have noticed that we have yet to touch what happens when we end our overlap. And so let's just go ahead and select all these. We're going to copy. We're going to paste. I'm just going to move that out a little bit. We're going to plug that in there. And we're going to grab our other actor and plug that in there. All right, and the only thing we need to change is we need to disable can rotate here. So we also don't actually need this duplicate set here. We literally could just use that. That's personal preference. It actually does not affect code execution speed at all, but that's just something I do just to keep the node count down. Okay, the reason why we disabled that is because if this statement is true that something is overlapped, something can set this to rotate, and when it ends its overlap, it can be set to not rotate. It's to be told not to. So it basically will change this from can rotate to can't rotate depending on whether or not our character is overlapping. Now, another thing we could do is we could set, we could connect our false statement up here and our false statement down there. I don't really think we need to, but let's go ahead and see if that is true. So we're going to go ahead and hit play. We'll walk up to our character, or walk up to the trigger. Everything's rotating. We walk away. It stops. Walk back in. And there we have it. So now what we need to check is to make sure that this is connecting to every light in every blueprint of our rotator light that we have in the scene. Go ahead and hit play. Walk up. Everything starts. Everything stops. Everything starts. Everything stops. Now, say that you want some of these things to behave a little bit differently. Again, like we covered in the first video, we can set some of them to have some properties that are overridden at runtime. This makes it a little bit more interesting without really changing anything or having, duplicate or somewhat duplicate blueprints and all that kind of stuff. And really the last thing we want to do is we only want these lights to turn on once our once the rotation is, once our character is overlapping our actor there. So let's go ahead and grab references to our spotlights in our rotor blueprint. Let's drag a pin from one of our light references, and we're going to set viz. Drag the execution pin into there. We're going to trigger yes on here, and we're going to copy this, paste that, and plug our other light reference into here so that they are both active, or they're both visible when rotating. However, when the character walks off, we're going to want to make sure that those lights turn back off. So let's go ahead and copy these nodes, wholesale, and plug that in there, and then disable visibility checkboxes. Make sure everything's saved. And we'll hit play again. This time, level starts, lights are off, that's a good sign. Walk in, everything turns back on. Walk out, everything shuts off. And so on and so forth. Now, you could also do things like activate audio. Now, for everyone's ears, I'm not going to be blaring some sort of alarm sound or anything like that, so I'm not really going to dive into audio. I don't really have anything lined up for that anyway. All audio in Unreal Engine is positional, when you drop it into something. If you have, say, like video that you've attached to something that has audio with it, it will play from where that is localized in the world, so it should work with stereo and surround sound natively. Should. Unreal Engine recently had a big audio update, and so everything is first class, top of line. Supports a large variety of new features. Really, the last thing I kind of want to go over is just kind of cleaning this up a little bit. If you double click on any of your different lines here, you can create a redirect node, and you can just help keep things from overlapping each other. I literally can do that all day. Cleaning up blueprint visibility is like a obsessive compulsive thing for me, and everything kind of has to be neat and balanced. Just clean everything up for legibility. When I'm feeling extra crazy, I'll even go in and just do that so that these lines don't cross through things. That is just a big, OCD thing for me. I try not to do it, but it does make things a lot easier to read. And I've always been complimented by all the people I've worked with about how clean my blueprints are and easy to read. So that is going to be it for this video. The next video is really just going to be doing a little bit with the construction script. I want to show how to create a construction script based modifier so that we can change the shape of our collision volume. And I'll come up with a few other things, the little knick-knacky type things to show, and just wrap up our introduction to blueprints series with that video. So again, thank you all for watching. If you like this video, please hit like on YouTube and subscribe to my YouTube channel. And if you want to get notified whenever I upload a new video, hit the bell icon and you should get those notifications, barring all the YouTube gods, planets aligning, and all that kind of goodness. So again, thank you all for watching, and I'll see you next time. Bye.